My name is Dhanabordee, and I will be presenting about the report published in the EJOR. The report title is Technology Improvement Strategy for Green Products Under Competition, the Role of Government Subsidy. Throughout the history, human activities have contributed to a large-scale increase in the energy burdens globally. This threat has brought attention to global efforts to increase the use of clean energy and green products. To address this burden, government provides financial support through subsidies for firms that decide to improve their green technology. This study examines the effects of government subsidy and the competitive dynamics between the firms with respect to the incentive to improve their green technology and improve the social welfare of the public. Two major models are used, Cornell competition and Stackelberg game. Please refer to Table 1 for the notations used in the models. In this study, each symmetric firm is engaged in a Cornell competition as they decide on the green product's production quantity. The demand function and the inverse demand function is defined as shown. The intensity of product is defined by theta, the basic market demand is A, and M represents the increase in basic market demand when the firm improves its technology. The cost of technology improvement is K. Given the subsidy amount, the firms select the green product production quantity Q that maximizes their own profit. The firm's payoff in the profit of selling its products, and the government's payoff is the social welfare effects. When no firm improves its technology, the basic market demands remains the same, and no firm needs to pay the cost of technology improvement. Solving the Nash equilibrium and applying the first order condition yields the following results for the equilibrium quantity, price, and profit for both firms. Applying the similar calculations, Nash equilibrium, when one of the firm improves its technology, can be summarized as follows. In the case where both firms improve their technology, no firm will have an advantage over the other as the competition becomes more fierce. Three Nash equilibriums can be solved based on the obtained information as follows. Although the firms may have reached the equilibrium, the result is not always the most beneficial, as the prisoner's dilemma exists, as shown in Figure 1. This is when both firms choose to improve their technology despite being able to obtain a higher profit by utilizing the existing technology instead. When the cost becomes large, it is no longer viable to invest in the improvement. And when competition becomes more intense, the equilibrium region where none of the firms improve and when the prisoner's dilemma exists also enlarges. When the presence of government subsidy, the Stackelberg model is conducted. The government acts as the leader that first sets the subsidy amount, and the two firms follow up with the Cornell competition, in the same sequence as described before. By a process of backward induction, the report demonstrates that the result of solving the two firms' production quantity decisions can be summarized in Table 2. Provided that the value of technology improvement cost is K, the following equilibriums for the firms exist. Now that the effectiveness of the government subsidy on the firms is defined, the report further discussed the government's maximization problems. From backwardation and solving the Cornell competition, this is the equilibrium subsidy amount when no firms improve their technology. This is the amount when one firm improves its technology, and this is the amount when both firms improve their technology. Figure 2 shows that the firms will stop the technology improvement when the cost becomes too large. The firms are more likely to improve the technology when the positive social welfare effect increases. Moreover, the effects of prisoner's dilemma previously described is much reduced. As this study takes the standpoint of the government to investigate the effectiveness of the subsidy, the following managerial insights are obtained. Figure 3 suggests that when basic market demand becomes relatively larger, the technology improvements becomes more attractive for both firms, as shown by an increase in the total quantity of green products. Figure 4 says that firms' profit diminishes as K increases. However, when only one firm improves its technology, it regains significant profit at the expense of the other that did not improve. In this case, the government's intervention through subsidy has damaged one of the two firms. Figure 5 shows that the equilibrium shifts from the case where both firms improve their technology to none of the firms improving the technology when the costs increase. Moreover, social welfare also diminishes as a result. Although across the board, the social welfare is greater when subsidy is present. All in all, the government should stress the importance of financial support to push firms to improve the green technology, raise the environmental awareness to increase the demand for the green products, increase and support R&D to reduce the cost of green technology improvement. The study applies a static game of complete information in the case where the firm's Cornell competition takes place. Each firm knows the payoff and simultaneously makes decisions. The dynamic game of complete and perfect information is also applied in the cases where the government subsidy exists and the Stackelberg game is conducted. The government is the leader in deciding the amount of subsidy, and the two firms will follow the Cornell competition. The study provides the clearer picture of how the firm's competitive dynamics and how the government subsidy affects the firm's social welfare. Despite the promising and encouraging results, the study is still limited in some areas. It suggests further consideration in quantity-related social effects to provide better management insights as one of the future research decisions.